Okay, hello everyone, welcome back. Before we continue to talk about this SQL constraints and triggers, I'd like to ask a question proposed by a student about the views we covered in the last section. So if you still remember, we have been talking about a concept called views, right? I provide you with an example, like we can create a view can drink as. It is followed by a sequence of queries, right, in SQL. Select drinker, beer from frequency and signers, and then we have where frequency.bar equals to sales.bar. I hope you still remember what this view means, right? This view denotes, this can drink can denote this sequence of SQLs. And in the later queries, we can use this can drink as a virtual table, right? Even though we know it doesn't really exist in the database system, it's a virtual table. And when in the near future, if we plan to use this can drink, we will replace this can drink with expressions based on these base tables as shown here. And I get an email from students asking why we need to use the views. The main reason is because for some queries or expressions like this one, this is very known, right? And for some of these queries in the near future, we probably may need to use it in some other queries. The following up queries. I will provide you with some examples. And now probably we need to have some queries like this. We need to select the drinker from the can drink, or we select beer from the can drink, or we select the drinkers dot address from can drink and drinkers, and where the can drink dot drinker equals to drinkers dot name, and we can also select the beer's name dot manufacturer from the can drink and the beers. So you can see in the following up this queries, we probably may need to use this can drink so many times. If we don't define this view here, for this query, we probably need to replace it with this complete expression here, right? It will be very long for the following up queries. Therefore, instead of writing this sequence of this expression so many times, we prefer to provide them for this sequence of this SQL instead, and we define it as a view is called can drink. Therefore, in the following expression, we can just use this can drink directly, and the system can replace this can drink's name with a sequence of SQL as shown here. So the can drink this view provides us with lots of convenience for following up queries. That's the reason why we need to use these views in SQL. As to what is a view, I can provide you with a comparison of views versus a temporary variable and a function we learned from the programming language. I hope you still remember, right? In the programming language, we have one concept is called temporary variable. If we have some numbers or some expressions which are very long, and we also plan to use it many times, then we can define a temporary variable, right, for it. Now we'll define a temporary variable. It's called temporal number equals to a times b plus c times d minus e times f plus g times h, and etc. This expression can be very long, and we prefer to provide it with a variable, a temporary number as shown here, right? In the flowing of the program, if we plan to use this number again, instead of writing this sequence of expression, we prefer to use this temporary number instead, right? I hope you can follow me, right? So this is called a temporary variable we can use in the programming language. So you can compare. Is a view the same or similar to a temporary variable or not? It seems we can use it in a very similar way, however, they are very different. The main reason is because of the allocation of the memory space or the storage space. For the temporary variable, in the memory we will allocate one space for it, right, for storing the number here. However, for views, we never store the view in hard drive. If you still remember, whenever in the near future we see the can drink, the system will replace this can drink with a sequence of SQL statements as shown here. In other words, this view is very different from the temporary variable, even though it looks very similar. And the view is more like a function actually. I hope you still remember function, right? In the programming language, we can define some functions. Like if we have a function, a complex expression, in the function we just return the sequence of the expression we used before. I hope you still remember what is the function, right? In the near future, if we call this function, the system will replace this function name with a sequence of the code inside this function, right, to execute it. Then it will be very similar to the view here. This view provides name. It's not a function, right? In the near future, if we call this a view name, the system will replace this view name with a sequence of code following it as in the definition. So you can follow me, right? So it's very different from a temporary variable. This one has a storage space. However, view doesn't have a storage space in the hard drive. It's more similar to a function. We just replace this name with a sequence of code in the definition, right? Okay, so this is about views. Why we need to use a view? Because in the following queries, we plan to use it. We probably need to use a view many times. If we have a time denoting this sequence of code here, it can be very convenient for us to write some other queries in a very short way, right? And what's the difference of this view versus a temporary variable and the function? It's different from temporary variable because the view doesn't have a storage space in our database systems. It's more similar to a function. It just replaces this view name with a sequence of code inside it. Okay, so this is my answer to the question proposed by a student, and let's come back to the slides. Before we show the checks on both attributes as well as tuples. However, sometimes we also want to check some conditions for the database system. So the attribute-based check is on a specific attribute, right? And the tuple-based check is on a specific tuple. However, sometimes we also want to check the tables or the relations as well as the overall database systems. If so, then we have to use this assertion. You can see it's different from the check on attribute and the tuples, right? It's on a higher level. It is in the same level as this relation and the views we defined before. These are for database schema elements. We can define this assertion as shown below. We can create assertion with some assertion name. This assertion is also defined based on some checks. We have checked on some conditions. So you can see the difference of this assertion versus a check, right? We can create assertion. It's very similar to create tables. In other words, this assertion is in the same level as tables and relations. It's for the overall database system, on all the tables inside the database system, right? And the conditions we define in the assertion can refer to any relations or attributes in the database schema. So it's the difference, right? Because this assertion is for the overall database system. We're monitoring all the relations inside database systems. Therefore, we can use all the relations and attributes here. Before we mentioned that if we use some other relations or attributes, we have to use subquery, right? Because it is inside one table, one relation. And this assertion is outside of the relations. It's for all the database system, right? So therefore, we can use all the relation attributes in the assertions without using the subqueries. We'll provide you with an example. Let's say we have a requirement in the sales table bar beer price where now no bar may charge an average of more than $5. To meet these requirements, we can create an assertion, rip off bars. It's also based on some checks. We have check branches. Inside, we have a query, not exists. I hope you still remember that this is operator. Exists followed by some conditions as well. Inside, we have select bar from sales. We can use all the attributes and the relations inside this condition, right? Therefore, we have select bar from sales, group by bar, right? Having $5 is smaller than average price. I hope you still remember the group by, right? And having. This having is a condition, right? It's based on the groups. After we group in this bar, this record by the bars, we have some computation for each of the group. The average price should be larger than $5. And inside this check, we should not find these kinds of bars, right? Therefore, we have not exist here. So this is the requirements. We need to ensure no bar may charge an average price more than $5. This is for the assertion. We'll provide you with another example. So for the assertion, now in the drinkers table, we have name, address, and phone number. In the bars table, we have bar name, address, and license. We have a requirement. There cannot be more bars than drinkers in our system. This is the requirements. We need to make sure it is valid during the running time of the system. And therefore, we can create an assertion, right? Because this one is for the overall database systems. We have to use the assertion to help us. We have to create an assertion. Field bar is the name. It is based on some checks. We have check parentheses. Inside it, we have a subquery, right? Because we are comparing the number of bars versus the number of drinkers in our system. We should get the number of bars, right? We can select count star, right, from bars is no greater than the count of drinkers in the drinkers table. So with this assertion, we can make sure there cannot be more bars than drinkers in our database system during the running time. I'd like to make more clarifications on the timing of these assertion checks. So in principle, we must check every assertion after every modification to any relations of a database system. And however, a clever system can observe that only certain changes could cause a given assertion to be violated. We can just use the field bar assertion we created before, right? No change to the beers can affect the field bar. Because the field bar, this assertion is created on the bars and drinkers, right? If we make some changes to the beers table, it has nothing to do for the field bar assertion, right? It will be very similar. Neither can be an insertion to the drinkers. If we add some more drinkers to these database systems, actually, in other words, we can add more drinkers here, right? If currently this assertion is valid, by adding more drinkers, this assertion will always be valid, right? Because here we have no larger than, no greater than. If right now the bar we have in the system is no greater than drinkers, so by adding more drinkers into the drinkers table, this assertion will still be true, right? Be valid. Therefore, we don't need to check all the time when we do some modification to any relation of a database system. And a clever system should have a clever way to check these assertions. And some of these modifications will not make this assertion to be violated. Then we can ignore these kinds of modifications. However, so far this assertion cannot do these kinds of clever things. For the assertion, we need to check all the modifications to any relations. If inside the database system we have 100 tables relations, then any changes to a relation, we need to check all the assertions there. It will be very inefficient, right? And we will have some problems because if we have a very large system, then the time cost on these assertions can be very costly. Therefore, we have to introduce another concept. It's called triggers instead.